Hello children, let us understand motion in a plane. Consider a particle is moving in xy plane along this curve. At t is equal to 0, it was at origin. At t is equal to t, it was at A. And at t is equal to t plus delta t, it was at B. At any point of time along this curve, particle's position is given by two coordinates, and they are x coordinate and y coordinate. Coordinate of point A is x comma y and coordinate of point B is x plus delta x comma y plus delta y. Its displacement from point A to point B is given by displacement vector AB. Let's say this is delta r. Then vector AB can be written as vector AC plus vector CB as per triangle law of vector addition. Vector AC is given by magnitude of AC into unit vector along x-axis. Vector CB is given by magnitude of CB into unit vector along y-axis. Magnitude of AC is x plus delta x minus x, that is delta x. Magnitude of CB is y plus delta y minus y, that is delta y. So vector AC is delta x into I cap and vector CB is delta y into j cap. So delta r is equal to delta x I cap plus delta y j cap. Now delta r upon delta t is equal to delta x upon delta t I plus delta y upon delta t j. If delta t is very small, that is it tends to 0, then delta r upon delta t we can write dr upon dt. So dr upon dt is equal to dx upon dt I plus dy upon dt j. We know that rate of change of displacement is called velocity. So v is equal to dx by dt is written as vx, that is horizontal component of velocity. dy by dt is written as vy, this is vertical component of velocity. So v is equal to vxi plus vyj. dv upon dt is equal to dvx upon dti plus dvy upon dtj. We know that rate of change of velocity is acceleration. So a is equal to dvx upon dt is ax. This is horizontal component of acceleration. dvy upon dt is ay. This is vertical component of acceleration. So a is equal to axi plus ayj. From equations 1, 2 and 3, we can say that 2D motion is a combination of two independent straight line motions, one along x-axis and another along y-axis. Now equations of motion along two axes x and y are given by these three equations as we have read in previous chapter. Now let us see one numerical based on the theory we have just read. A particle moves in xy plane with a constant acceleration of 1.5 meter per second square in the direction, making an angle of 37 degree with the x-axis. At t is equal to 0, the particle is at the origin and its velocity is 8 meter per second along the x-axis. Find the velocity and the position of the particle at t is equal to 4 seconds. It is given that at t is equal to 0, particle was at origin. Its acceleration is constant, which is 1.5 meter per second square. Acceleration vector makes an angle of 37 degree with the positive x-axis. It is also given that initial velocity is along the x-axis. That means ux equal to 8 meter per second and uy is equal to 0. Horizontal component of the acceleration will be a cos 37. A is 1.5, value of cos 37 is 4 by 5. So ax equal to 1.2 meter per second square. Similarly, ay is equal to a sin 37. So that is 1.5 into value of sin 37 is 3 by 5. So ay is equal to 0.9 meter per second square. Ux is given as 8 meter per second. So Vx equal to Ux plus Axt. Ux is 8 and Ax is 1.2. So Vx equal to 8 plus 1.2 t. At t is equal to 4 seconds, Vx comes out to be 12.8 meter per second. Similarly, Vy is equal to Uy plus Ayt. Uy is 0, Ay is 0.9 meter per second square. So Vy is equal to 0.9 t. At t is equal to 4 seconds, Vy is equal to 3.6 meter per second. So magnitude of V is equal to under root Vx square plus Vy square. So it comes out to be 13.3 meter per second. Now the direction of velocity vector, let's say it makes an angle of theta with the positive x-axis. So tan theta is equal to Vy upon Vx, or theta is equal to tan inverse. Vy is 3.6 and Vx is 12.8. So theta is equal to tan inverse 9 upon 32. X equal to uxt plus half axt square. Ux is given as 8. Ax we have figured out at 1.2 meter per second square. So x equal to 8t plus 1 by 2 into 1.2 t square. At t is equal to 4 second, x comes out to be 41.6 meter. Similarly, y is equal to uit plus 1 by 2 ayt square. Uy is 0, ay we have figured out as 0.9 meter per second square. So y is equal to 0.9 upon 2 t square. At t is equal to 4 second, y is 7.2 meter. So position at t is equal to 4 second will be 41.6 meter, 7.2 meter. Now let us understand projectile and projectile motion. Suppose a particle is thrown obliquely near the Earth's surface. Then it travels along a curved path. Such a particle is called as projectile and its motion is called as projectile motion. There are two assumptions here. One, it is close to the Earth's surface, so that acceleration due to gravity is constant. And two, air resistance is negligible. Suppose a particle is thrown from point O on the ground at t is equal to 0 with initial velocity u at an angle theta with the horizontal, then it travels on this curved path known as parabolic path. It goes till maximum height h and then comes down at point Q on the ground. Point O is known as point of projection, t is equal to 0 is known as time of projection, u is known as velocity of projection, theta is known as angle of projection, h is known as maximum height, r is known as horizontal range or range, and total time taken from point O to point Q is known as time of flight. Let us analyze this motion. First is horizontal motion. Velocity of projection is u, angle of projection is theta. So ux equal to u cos theta and uy is equal to u sin theta. At any point of time, particle experiences only vertical acceleration, that is acceleration due to gravity that works vertically downwards, no horizontal acceleration. So ax equal to 0 and ay is equal to minus g. Vx equal to ux plus axt. Ax equal to 0, so Vx equal to ux and ux equal to u cos theta. So Vx equal to u cos theta. It is independent of t. Means horizontal component of velocity remains constant, that is u cos theta, throughout the journey. Horizontal displacement x is given by uxt plus half axt square. Ax equal to 0. So x equal to uxt or u cos theta into t. Vertical motion. Ay is equal to minus g, uy is equal to u sin theta. So equations of motion in vertical journey are given by Vy is equal to uy minus gt, y is equal to uit minus half gt square, and Vy square equal to uy square minus 2gy. Let us calculate the time of flight. Y is equal to uit minus half gt square as it is written here. Total vertical displacement when the particle reaches at the same level. Y is equal to 0. Uy is u sin theta. So u sin theta t minus half gt square. This gives quadratic in t. So values of t are 0 and 2u sin theta upon g. 0 is not possible, so we will take t is equal to 2u sin theta upon g. Usually time of flight is denoted by capital T. So capital T is equal to 2u sin theta upon g or is equal to 2uy upon g. Horizontal range. X is equal to u cos theta into t. So x equal to u cos theta into t is time of flight. Time of flight, we have just calculated 2u sine theta upon g. So x equal to 2u square sine theta cos theta upon g, or it can be written as u square into 2 sine theta cos theta upon g. 2 sine theta cos theta is sine 2 theta. So it can be written as equal to u square sine 2 theta upon g, or it can be also written as 2 into u sine theta into u cos theta, that is ux into uy upon g. Maximum height calculation. At peak point P, vertical component of velocity, that is Vy, is equal to 0. Let us assume time taken to reach point P is t. So Vy is equal to uy minus gt. Vy is equal to 0, uy is equal to u sine theta. So t is equal to u sine theta upon g. This is half of total time taken. Vertical displacement h is equal to uyt minus half gt square. Put the value of t as u sine theta upon g. So h comes out to be u square sine square theta upon 2g. This is the formula for calculation of maximum height. Maximum range. Range is given by u square sine 2 theta upon g. Range will be maximum when sine 2 theta is equal to 1, or 2 theta is equal to 90 degree, or theta is equal to 45 degree. And the maximum range will be u square upon g. Equation of trajectory. Equation of trajectory is the relation between horizontal and vertical displacement, that is x and y, independent of time. Horizontal displacement x is given by uxt. So t is equal to x upon ux, and ux is equal to u cos theta. So t is equal to x upon u cos theta. Vertical displacement y is equal to uyt minus half gt square. Put the value of t as x upon u cos theta. So y is equal to x tan theta minus gx square upon 2u square cos square theta. This is the equation of trajectory. Equation of trajectory when range is known. Y is equal to x tan theta in bracket 1 minus x upon r. This formula can be found from here, substituting u square sine 2 theta upon g as r. Let us see few questions based on the theory we have just read. First question, a football is kicked with a velocity of 20 meters per second at an angle of 45 degree with the horizontal. Part A, find the time taken by the ball to strike the ground. Part B, find the maximum height it reaches. Part C, how far away from the kick does it hit the ground? Take G is equal to 10 meters per second square. It is given that velocity of projection is 20 meters per second. Angle of projection is 45 degree with horizontal. Part A, time of flight is given by 2u sine theta upon g. U is given as 20 meters per second, theta is given as 45 degree, and g is given as 10 meters per second square. So time of flight comes out to be 2.8 seconds. Maximum height is given by u square sine square theta upon 2g. U is given as 20 meters per second, theta is given as 45 degree, g is given as 10 meters per second square. So maximum height it reaches is 10 meters. Part C, range is given by u square sine 2 theta upon g. Substituting the value for u, theta and g, range comes out to be 40 meters. Second question, a helicopter on food relief mission flying horizontally with a speed u at an altitude h has to drop a food packet for a victim standing on the ground. At what distance from the victim should the packet be dropped? The victim stands in the vertical plane of the helicopter's motion. It is given that a helicopter is flying horizontally with constant speed u at height h from the ground. A victim is standing at point A. When the helicopter is at point B, it has to drop a food packet such that it reaches the ground at point A. We have to figure out the distance between B and A. OA is equal to ux into t. Ux is horizontal component of velocity, that is given as u. So OA is equal to u into t. That is our first equation. Now, vertical displacement of the food packet is given by minus h as the food packet is coming down. So, minus h is equal to uyt minus half gt square. Uy is equal to 0, means initial vertical component of the velocity is 0. So, minus h is equal to 0 minus half gt square. So, t comes out to be under root 2h upon g. Put this value of t in this equation. So, OA is equal to u under root 2h upon g. Now, apply Pythagoras theorem in this right angle triangle. So, AB is equal to under root OA square plus OB square. So, that comes out to be under root u square into 2h upon g plus h square. So, AB is equal to under root 2u square h upon g plus h square. Now, let us understand a particle's projectile motion in 6 different scenarios. I have listed these scenarios here. Scenario 1. Ground to ground projectile motion. A particle is projected from a point A on the ground with initial velocity u at an angle theta with the horizontal, and it hits the ground at point B. We have seen this scenario in the previous video where we have got the formula for time of flight, maximum height, range and maximum range. In scenario 2, 3 and 4, a particle is projected from some height. In scenario 2, it is projected horizontally. In scenario 3, it is projected upwards at an angle theta with the horizontal. In scenario 4, it is projected downwards at an angle theta with the horizontal. In scenario 5, it is projected up the plane. And in scenario 6, it is projected down the plane. We will start with scenario 2. In all the scenarios, we will figure out ux, uy, vx, vy, ax, ay and calculate time of flight, range and maximum height. Second scenario. Suppose the height of tower is h. A particle is projected horizontally with initial velocity u. It hits the ground at A. Then we have to calculate time of flight and range. Ux is equal to u as the particle is projected horizontally and uy is equal to 0. Ax equal to 0 and ay is equal to minus g as the particle at any point of time experiences only acceleration due to gravity that works vertically downwards. When the particle hits the ground, vertical displacement is minus h as the particle is coming down. So minus h is equal to uyt minus half gt square. Uy is 0, so minus h is equal to 0 minus half gt square. So t comes out to be equal to under root 2h by g. This is time of flight. Range is equal to ux into t. Ux equal to u. So range is equal to u under root 2h by g. Suppose we want to calculate the velocity of the particle when it hits the ground, that is Va. So Vy square is equal to uy square minus 2g into h is minus h as the particle is coming down. So Vy square is equal to 2gh or Vy is equal to under root 2gh. So magnitude of velocity at point A will be equal to under root Vx square plus Vy square, and Vx is same as initial velocity. So Vx equal to u and Vy we have figured out is under root 2gh. So Vy square is 2gh. So magnitude of velocity will be equal to under root u square plus 2gh when it hits the ground. And its direction, let's say it makes an angle theta with the horizontal. So tan theta is equal to Vy upon Vx. Third scenario, a particle is projected upwards with initial velocity u making an angle theta with the horizontal from a tower of height h. Ux equal to u cos theta and uy is equal to u sin theta. Ax equal to 0, ay is equal to minus g. When the particle hits the ground, its vertical displacement is minus h as it is coming down. So minus h is equal to uyt minus half gt square. Uy is equal to u sin theta. So minus h is equal to u sin theta t minus half gt square. This equation gives time of flight t. Range is equal to ux into t. Ux equal to u cos theta. So r is equal to u cos theta into t. Knowing t, we can calculate r. Suppose we want to calculate the velocity of the particle at A when it hits the ground. So Vy square is equal to Uy square minus 2g into minus h. So Vy square is equal to Uy is equal to U sin theta. So U sin theta whole square plus 2gh. Or Vy square is equal to U square sin square theta plus 2gh. Vx equal to Ux as the horizontal component of velocity remains constant. That is equal to U cos theta. So magnitude of Va means magnitude of the velocity of the particle when it hits the ground is equal to under root Vx square plus Vy square. Vx square is equal to U square cos square theta and Vy square is equal to U square sin square theta plus 2gh. So magnitude of Va is equal to under root U square plus 2gh. It is exactly the same as in scenario 2 when the particle hits the ground. Let us say velocity vector makes an angle alpha with the horizontal. Then tan alpha is equal to Vy upon Vx. Fourth scenario, suppose a particle is thrown downwards making an angle theta with the horizontal from a tower of height h. Ux equal to U cos theta and Uy is equal to minus U sin theta. Ax equal to 0, Ay is equal to minus g. When particle hits the ground, its vertical displacement is minus h as it is coming down. So minus h is equal to Uyt minus half gt square. Ui is equal to minus U sin theta. So minus h is equal to minus U sin theta t minus half gt square. Multiply both the sides with minus 1. So h is equal to U sin theta t plus half gt square. This equation gives the time of flight t. Range r is equal to ux into t. Ux equal to u cos theta. So r is equal to u cos theta into t. Knowing t, we can calculate range r. Suppose we want to calculate the velocity of the particle when it hits the ground. So Vy square is equal to Uy square minus 2g into minus h. Vy square is equal to Uy is equal to minus U sin theta. So Uy square is equal to minus U sin theta whole square plus 2gh. Or Vy square is equal to U square sin square theta plus 2gh. Vx equal to Ux as horizontal component of velocity remains constant and that is equal to U cos theta. Magnitude of Va is equal to under root Vx square plus Vy square. Vx square is equal to U square cos square theta and Vy square is equal to U square sin square theta plus 2gh. So magnitude of Va is equal to under root U square plus 2gh. It is same as in scenario 2 and scenario 3 when the particle hits the ground. Tan alpha is equal to Vy upon Vx. Scenario number 5. Projectile motion up the plane. Consider a particle is projected from point A with initial velocity u. It makes an angle theta with the horizontal. It hits the plane at point B. Angle of inclination of the plane is alpha. Suppose along the plane is x-axis and perpendicular to the plane is y-axis. Component of initial velocity u along the plane will be ux and that will be equal to u cos theta minus alpha and ui is equal to u sin theta minus alpha. Next we will calculate ax and ay. Consider a point C on this projectile path. G works vertically downwards. Extend this vector till it meets AN at point M. In this right angle triangle, this angle is equal to 90 minus alpha. AX is parallel to the plane and this is transversal. So this angle is equal to this angle. This angle is equal to 90 minus alpha. So this angle will also be equal to 90 minus alpha. So Ax is equal to minus g cos 90 minus alpha. That will be equal to minus g sin alpha. Similarly, Ay is equal to minus g sin 90 minus alpha. That will be equal to minus g cos alpha. Now when particle hits the plane at B, vertical displacement will be equal to 0. So y is equal to uyt plus 1 by 2 ayt square. Y is equal to 0, uy is equal to u sin theta minus alpha, and ay is equal to minus g cos alpha. So 0 is equal to u sin theta minus alpha t plus 1 by 2 minus g cos alpha t square. This gives a quadratic in t. Values of t will be t is equal to 0 and t is equal to 2u sin theta minus alpha upon g cos alpha. So time of flight will be equal to 2u sin theta minus alpha upon g cos alpha. Now in this right angle triangle, AP upon AB is equal to cos alpha. Component of initial velocity along the horizontal direction will be u cos theta. So AP is equal to u cos theta into time of flight. So AP is equal to u cos theta into 2u sin theta minus alpha upon g cos alpha. That will be equal to 2u square sin theta minus alpha cos theta upon g cos alpha. So AB is equal to AP upon cos alpha. AB is equal to range R. So R is equal to 2u square sin theta minus alpha cos theta upon g cos square alpha. Now we know that 2 sin A cos B is equal to sin A plus B plus sin A minus B. So R is equal to u square sin 2 theta minus alpha plus sin minus alpha upon g cos square alpha. Sin minus theta equal to minus sin theta. So R is equal to u square sin 2 theta minus alpha minus sin alpha upon g cos square alpha. Now to get the maximum range, dr upon d theta should be equal to 0. So dr upon d theta will be equal to u square upon g cos square alpha 2 cos 2 theta minus alpha minus 0. So condition for maximum range will be 0 is equal to cos 2 theta minus alpha or 2 theta minus alpha is equal to pi by 2. So this is the condition for maximum range. Putting this value here, maximum range will be equal to u square sin 90 minus sin alpha upon g cos square alpha. So R maximum will be equal to u square upon g cos square alpha into 1 minus sin alpha. So you may keep in mind these formulas: time of flight, range, maximum range, condition for maximum range. Scenario number 6. Projectile motion down the plane. Consider a particle is projected from point A with initial velocity u. It makes an angle theta with the horizontal. It hits the plane at point B. Angle of inclination of the plane is alpha. Along the plane is x-axis and perpendicular to the plane is y-axis. This angle is equal to alpha as this is parallel to this and this is transversal. So angle this is equal to angle this. So component of u along this plane, that is ux, will be equal to minus u cos theta plus alpha, and uy is equal to u sin theta plus alpha. Ax and ay will be same as explained in scenario number 5. So Ax is equal to minus g sin alpha and Ay is equal to minus g cos alpha. When particle hits the plane at point B, vertical displacement is equal to 0. So y is equal to uyt plus 1 by 2 ayt square. Y is equal to 0, uy is equal to u sin theta plus alpha and ay is equal to minus g cos alpha. So 0 is equal to u sin theta plus alpha into t plus 1 by 2 into minus g cos alpha into t square. This gives a quadratic in t. Values of t will be equal to 0 or 2u sin theta plus alpha upon g cos alpha. T cannot be equal to 0, so time of flight t is equal to 2u sin theta plus alpha upon g cos alpha. Now, QP can be calculated as component of u parallel to horizontal, that is u cos theta into time of flight. So QP is equal to u cos theta into 2u sine theta plus alpha upon g cos alpha. In this right angle triangle, this angle is equal to alpha, as this is parallel to this and this is transversal. So cos alpha is equal to QP upon AB. AB is range R. So R is equal to QP upon cos alpha. That is equal to 2u square sine theta plus alpha cos theta upon G cos square alpha. We know that 2 sine A cos B is equal to sine A plus B plus sine A minus B. So R is equal to u square into sine 2 theta plus alpha plus sine alpha upon G cos square alpha. For maximum range, dr upon d theta is equal to 0. So dr upon d theta is equal to u square upon G cos square alpha into 2 cos 2 theta plus alpha plus 0. Or 0 is equal to cos 2 theta plus alpha, or cos 90 is equal to cos 2 theta plus alpha. So condition for maximum range is 2 theta plus alpha is equal to pi by 2, or theta is equal to pi by 4 minus alpha by 2. Also, maximum range is equal to u square upon G cos square alpha, and value of 2 theta plus alpha is equal to pi by 2. So that is equal to u square upon G cos square alpha into sine pi by 2 plus sine alpha. That is equal to u square upon G cos square alpha 1 plus sine alpha. So you need to keep in mind these formulas: formula for time of flight, range, condition for maximum range, and maximum range. Let us see a few questions based on the theory we have just gone through. First question: from the top of a tower, a stone is projected with speed 15 meter per second at an angle of 37 degree with horizontal, as shown in the figure. Calculate the time of flight, horizontal range, speed just before striking the ground. Take G is equal to 10 meter per second square. Height of the tower is given as 20 meter. A stone is projected from point Q downwards with initial velocity 15 meter per second at an angle of 37 degree with horizontal. The stone strikes the ground at point A. U is given as 15 meter per second. Ux, that is horizontal component of U, will be U cos 37, and vertical component will be minus U sin 37 degree. So Ux is equal to 15 into value of cos 37 degree is equal to 4 by 5. So Ux is equal to 12 meter per second, and Uy is equal to minus 9 meter per second. Now when stone strikes the ground, its vertical displacement is minus 20 meter. So h is equal to u by t minus 1 by 2 gt square. H is minus 20, uy is minus 9, g is given as 10 meter per second square. So minus 20 is equal to minus 90 minus 5t square. This is a quadratic in t. Values of t are minus 3.093 or 1.293 second. Time cannot be negative, so this value is ignored. So time of flight is equal to 1.293 seconds. Horizontal range, this is given by ux into time of flight. Ux we have calculated as 12 meter per second, and time of flight is 1.293 seconds. So range is equal to 15.516 meter. Now we have to calculate the speed just before striking the ground. So VA is given by under root u square plus 2gh. U is 15 meter per second, g is 10 meter per second square, and h is 20 meter. So VA comes out to be 25 meter per second. Second question: a projectile can have the same range r for two angles of projection. If T1 and T2 be the time of flight in two cases, then show that T1 T2 is proportional to r. Suppose a particle is projected with initial velocity u, first at an angle theta 1, then at an angle theta 2 to get the same range r. Then R1 is equal to u square sine 2 theta 1 upon g, and R2 is equal to u square sine 2 theta 2 upon g. It is given that R1 is equal to R2 is equal to R, or u square into sine 2 theta 1 upon g is equal to u square into sine 2 theta 2 upon g, or sine 2 theta 1 is equal to sine 2 theta 2. General solution for sine theta is equal to sine alpha is theta is equal to n pi plus minus 1 to power n alpha. For n is equal to 1, write 2 theta 1 in place of theta and 2 theta 2 in place of alpha. So 2 theta 1 is equal to pi plus minus 1 to power 1 into 2 theta 2. So 2 theta 1 is equal to pi minus 2 theta 2, or theta 1 is equal to pi by 2 minus theta 2. Now time of flight in first case, that is t1 is equal to 2u sine theta 1 upon g, and t2 is equal to 2u sine theta 2 upon g. So t1 t2 is equal to 4u square upon g square sine theta 1 into sine theta 2. Put the value of theta 2 from here. That is theta 2 is equal to pi by 2 minus theta 1. So T1 T2 is equal to 4u square upon g square sine theta 1 into cos theta 1. Now it can be broken as T1 T2 is equal to 2 by g into u square into 2 sine theta 1 cos theta 1 upon g. 2 sine theta 1 cos theta 1 is equal to sine 2 theta 1. So T1 T2 is equal to 2 upon g u square sine 2 theta 1 upon g, and u square sine 2 theta 1 upon g is equal to R1, and R1 is equal to R. So T1 T2 is equal to 2 upon g R. So T1 T2 is proportional to R, hence proved. Third question, an object is first projected up the plane, then down the same inclined plane with same initial velocity u. Maximum range down the plane is thrice as compared to up the plane. Calculate the angle of inclination of the inclined plane. So if you know the formula, it can be done within seconds. And if you don't know the formula, then it will take some time to figure out the formula. So maximum range of the projectile down the inclined plane is given by R max down is equal to u square upon g cos square alpha into 1 plus sin alpha, where alpha is the angle of inclination of inclined plane. Maximum range of the projectile up the inclined plane is given by R max up is equal to u square upon g cos square alpha into 1 minus sin alpha. It is given that R maximum down is equal to 3 times of R maximum up. So u square upon g cos square alpha into 1 plus sin alpha is equal to 3 times u square upon g cos square alpha into 1 minus sin alpha. So this gives 1 plus sin alpha is equal to 3 times of 1 minus sin alpha, or 1 plus sin alpha is equal to 3 minus 3 sin alpha, or 4 sin alpha is equal to 3 minus 1, or sin alpha is equal to 1 by 2. And we know that 1 by 2 is the value of sin 30. So comparing both sides, alpha is equal to 30 degree. So angle of inclination of the inclined plane is 30 degree. Now let us understand relative motion. First, relative position. Consider two particles, particle A and particle B, in 2D Cartesian coordinate plane. Position of A is given by vector RA and position of B is given by vector RB. RA represents position of A with respect to origin and RB represents position of B with respect to origin. Then position of A with respect to B is given by vector RA, B, and that is equal to vector RA minus vector RB. Similarly, position of B with respect to A is given by vector RB, A, and that is equal to vector RB minus vector RA. Relative position can be represented in either of these two ways, as vector R A, B or vector R A / B. Now let us understand relative velocity. We will consider 4 scenarios. Scenario 1, Consider two particles, particle A and particle B. They are moving towards each other along the line joining them with velocities VA and VB respectively. Then velocity of A with respect to B is given by vector VA comma B, and that is equal to vector VA minus vector VB. This can be written as vector VA plus of minus vector VB. Minus vector VB will be opposite of vector VB. So this vector represents vector VA comma B, where magnitudes of both the vectors will be added and direction will be that of vector VA. Second scenario, consider two particles A and B are moving away from each other along the line joining them with velocities VA and VB respectively. Then velocity of particle A with respect to B is given by vector VA comma B, and that is equal to vector VA minus vector VB. This can be written as vector VA plus of minus vector VB. Minus vector VB will be opposite to vector VB. So this represents vector VA comma B, where magnitudes of both the velocities will be added and direction will be that of vector VA. Third scenario, consider two particles, particle A and particle B. They are moving with velocities VA and VB, making an angle alpha and beta respectively with the line joining them. These particles may or may not collide. However, at certain point of time, they will be at a minimum distance with each other. Then we say velocity of approach is component of vector VA comma B along the line joining A and B. Magnitude of component of vector VA comma B is equal to VA cos alpha minus VB cos beta. Fourth scenario, consider two particles, particle A and particle B. They are moving with velocities VA and VB, making an angle alpha and beta respectively with the line joining them. You can see that these particles will never collide. So we say that velocity of separation is component of vector VA comma B along the line joining A and B. So magnitude of component of vector VA comma B will be equal to VA cos alpha minus VB cos beta. Now let us understand relative acceleration. Consider two particles, particle A and particle B are moving with accelerations AA and AB respectively. Then acceleration of particle A with respect to B is given by vector A comma B is equal to vector AA minus vector AB. Similarly, acceleration of particle B with respect to A is given by vector AB comma A, and that is equal to vector AB minus vector AA. Now let us see how to calculate minimum distance between two moving objects with the help of this question. Two bikers are standing on two mutually perpendicular roads at a distance of 100 meter and 60 meter respectively. They start moving towards intersection at a speed 25 meter per second and 10 meter per second respectively. Calculate the minimum distance between them and time taken to reach it. Suppose these are two mutually perpendicular roads. Their point of intersection is O. Biker A is standing at a distance of 100 meter from O and biker B is standing at a distance of 60 meter from O. At t is equal to 0, distance between them is AB. At t is equal to 0, biker A starts moving towards O with a speed 25 meter per second and biker B starts moving towards O with a speed 10 meter per second. We have to calculate after what time distance between them will be minimum. Suppose that distance is S. In time t, the distance traveled by A will be 25 t meters and by B it will be 10 t meters. So now distance between them, that is S, is equal to under root 100 minus 25 t whole square plus 60 minus 10 t whole square. For minimum or maximum S, ds by dt should be equal to 0. So we will do ds by dt. So ds by dt comes out to be this. And value of t comes out to be 4.28 seconds. Put this value in this. So minimum distance will be 18.57 meter. Now let us see applications of relative motion. First scenario is relative motion in river flow. We will consider two cases in it. First case, upstream downstream motion, and second case, across the river motion. First case, suppose river is flowing with velocity v and a swimmer is swimming with velocity u along the flow. Then relative velocity of swimmer with the stream will be u plus v. If the swimmer is swimming with velocity u but against the flow, then the relative velocity of swimmer against the stream will be u minus v. Second case, across the river. Suppose swimmer is standing at point A. River is flowing with velocity v. Swimmer can swim with velocity u. Swimmer wants to end up at point B. That means he or she wants to travel minimum distance. Then swimmer should start swimming at an angle theta with line AB. Suppose swimmer wants to cross the river in minimum time, then the direction of swimmer should be along the line AB so that he or she ends up at point B dash. Distance between B and B dash is called as drift. Now let us see these two questions based on relative motion in river flow. First question, a river 400 meter wide is flowing at a rate of 2 meter per second. A boat is sailing at a velocity of 10 meter per second with respect to the water in a direction perpendicular to the river. Part A, find the time taken by the boat to reach the opposite bank. Part B, how far from the point directly opposite to the starting point does the boat reach the opposite bank? Suppose this is river. Width of the river is given as 400 meter. Velocity of river water is v. Velocity of boat is u with respect to water. It is sailing along the line AB, that is perpendicular to the flow of water. Now time taken in this case will be minimum time. So time taken will be distance upon velocity of boat with respect to water. So that is equal to 400 upon 10, that is 40 seconds. Part B, how far from the point directly opposite to the starting point does the boat reach the opposite bank? Since the boat is sailing along the line AB, so because of flow of the water, it will end up somewhere at point B dash. So we have to calculate BB dash, that is drift. And drift happens because of the flow of water. So drift BB dash will be velocity of water into time taken by the boat to cross the river. So it will be 2 into 40, that is 80 meter. So BB dash is 80 meter. Second question, a swimmer wishes to cross a 500 meter wide river flowing at 5 km per hour. His speed with respect to water is 3 km per hour. Part A, if he heads in a direction making an angle theta with the flow, find the time he takes to cross the river. Part B, find the shortest possible time to cross the river. This is the river. Let us assume v is the velocity of river. U is the velocity of swimmer with respect to river water. He starts in a direction making an angle theta with the flow of water. Velocity component that counters the flow of water is u cos theta, and velocity component that helps to cross the river, that is along line AB, is u sin theta. So time taken by the swimmer in this case will be distance 500 upon velocity component along line AB, and that is u sin theta. U is given as 3 km per hour or 3 into 5 by 18 meter per second. So T is equal to 500 upon 3 into 5 by 18 sin theta. So T comes out to be 10 upon sin theta minutes. Part B, find the shortest possible time to cross the river. To cross the river taking shortest possible time, swimmer has to head in EB direction. So in that case, time taken will be 500 upon U. U is 3 into 5 by 18 meter per second. So it will be 500 upon 3 into 5 by 18. That comes out to be 600 seconds or 10 minutes. Now let us see these two questions to understand relative motion in wind. First question, an aeroplane has to go from a point A to another point B 500 km away due 30 degrees east of north. A wind is blowing due north at a speed of 20 meters per second. The air speed of the plane is 150 meters per second. Part A, find the direction in which the pilot should head the plane to reach the point B. And part B, find the time taken by the plane to go from A to B. This is north, this is south, this is east, and this is west. A plane has to start from point A and reach point B, which is 500 kilometers away. Line AB makes 30 degree with north towards east. Suppose pilot starts flying in AC direction, which is theta degree from line AB. U is the velocity of plane and V is the velocity of wind. We will resolve U and V into two components, one along line AB and another perpendicular to it. Perpendicular to it components will cancel each other and along the AB will help reach the plane towards the target. So U is given as 150 meter per second, V is given as 20 meter per second. Component of U along the line AB will be U cos theta and perpendicular to it will be U sin theta. Similarly, component of V along the line AB will be V cos 30 degree and perpendicular to it will be V sin 30 degree. So perpendicular components will cancel each other. So U sin theta is equal to V sin 30 degree or theta is equal to sin inverse 1 by 15 east of line AB. Part B. Now adding these two components means U cos theta and V cos 30 degree, which will help the plane reach the target. So T is equal to AB. AB is given as 500 kilometers. So 500 into 10 to power 3 meters upon U cos theta plus V cos 30 degrees. So after calculation, T comes out to be approximately 49.9 minutes or 50 minutes. Second question, two friends A and B are standing a distance x apart in an open field and wind is blowing from A to B. A beats a drum and B hears the sound T1 time after he sees the event. A and B interchange their positions and the experiment is repeated. This time, B hears the drum T2 time after he sees the event. Calculate the velocity of sound in still air V and the velocity of wind U. Neglect the time light takes in traveling between the friends. Suppose A is sitting here with drum and B is here. Distance between them is given as x. Wind is blowing from A to B with speed U and sound travels with speed V. Now in case 2, they interchange their positions. A comes here with drum and B is here. Distance between them is same. Wind direction is also same. Direction of sound changes. So in case 1, wind and sound direction is same. In case 2, they are in opposite directions. In case 1, velocity of sound relative to wind will be V plus U. In second case, velocity of sound related to wind will be V minus U. So in case 1, time taken for sound to travel from A to B will be T1. So T1 is equal to x upon V plus U. In case 2, T2 will be equal to x upon V minus U. Now solving these two equations for V and U, V comes out to be x by 2 in bracket 1 by T1 plus 1 by T2 and U comes out to be x by 2 in bracket 1 by T1 minus 1 by T2. Now let us see this question to understand relative motion in rain. A man standing on a road has to hold his umbrella at 30 degree with the vertical to keep the rain away. He throws the umbrella and starts running at 10 km per hour. He finds that raindrops are hitting his head vertically. Find the speed of raindrops with respect to part A road and part B the moving man. Suppose man is standing here holding his umbrella like this because the raindrops are coming from a direction which is 30 degree from the vertical. Now the man throws his umbrella and starts running in this direction. So the raindrops appear to be falling on his head vertically. Here V r comma g represents velocity of raindrops with respect to ground. V m comma g represents velocity of man with respect to ground, and V r comma m represents velocity of rain with respect to man. We will resolve VRG into two components, one vertical component and one horizontal component. We will equate horizontal component with VMG and vertical component will be VRM. In first part, we have to calculate VRG and in second part, we have to calculate VRM. So horizontal component of VRG will be equal to VRG sine 30 and that will be equal to VMG. So VMG is equal to VRG sine 30. So VRG comes out to be 20 km per hour as VMG is given as 10 km per hour. In part B, VRM is equal to VRG cos 30. So VRM comes out to be 10 root 3 km per hour. Now let us understand relative motion in moving platform. We will consider two cases in it. First, when the platform is moving horizontally with uniform speed, and second, when platform is moving vertically with uniform speed. First case, consider a trolley is moving horizontally with uniform speed v. A person A is standing on the trolley holding a ball, and observer B is standing on the road. We will consider three cases in it. First, when person A throws the ball vertically upwards. Second, when the person throws the ball making an angle theta with the horizontal in the direction of movement of trolley. In third case, person throws the ball making an angle theta with the horizontal but in opposite to the movement of trolley. In case 1, person A will see the ball moving either in vertically upwards or downward direction. Observer B will see the ball moving in a parabolic path. Here the horizontal component of ball's velocity is equal to velocity of trolley. In second case, for A, horizontal component of ball's velocity will be u cos theta and vertical component of ball's velocity will be u sin theta. For B, horizontal component of ball's velocity will be u cos theta plus v and vertical component of ball's velocity will be u sin theta. In this case, for A, horizontal component of ball's velocity will be u cos theta and vertical component of ball's velocity will be u sin theta. For B, horizontal component of ball's velocity will be u cos theta minus v and vertical component of ball's velocity will be u sin theta. Second case, when platform is moving vertically up or vertically down with uniform speed v. In both the cases, suppose person A throws the ball at an angle theta with the horizontal. Then in this case, for A, horizontal component of ball's velocity will be u cos theta and vertical component of ball's velocity will be u sin theta. For B, horizontal component of ball's velocity will be u cos theta and vertical component of ball's velocity will be u sin theta plus v. In this case, for A, horizontal component of ball's velocity will be u cos theta and vertical component of ball's velocity will be u sin theta. For B, horizontal component of ball's velocity will be u cos theta and vertical component of ball's velocity will be u sin theta minus v. Let us see this question. A person is standing on a trolley which moves horizontally with uniform velocity 3i meter per second. At t is equal to 0, person throws a ball with velocity 3 cos theta I plus 3 sin theta j meter per second with respect to himself. He always sees the ball overhead. Then theta is equal to what? Suppose trolley is moving horizontally with uniform velocity 3i meter per second. A person who is standing on the trolley throws the ball making an angle theta with the horizontal such that u is equal to 3 cos theta I plus 3 sin theta j. This matches with first scenario. In this case, person throws the ball vertically upwards and he sees the ball overhead, either moving up or moving down. In this case, horizontal component of ball's velocity is equal to velocity of the trolley. So in this case also, horizontal component of ball's velocity should be equal to 3i. That means 3 cos theta should be equal to 0. That means cos theta is equal to cos 90 or theta is equal to 90 degrees. That means person should throw the ball vertically upwards. So theta is equal to 90 degrees is the answer. Now let us see relative motion in lift. We will consider two cases. Case 1 when lift is accelerating upwards, and case 2 when lift is accelerating downwards with constant acceleration a. In case 1, a person who is standing in the lift experiences a upwards and g downwards. So net acceleration upwards will be a plus g. In this case, person experiences both the accelerations downwards. So net acceleration that will be equal to a minus g downwards. Let us see this question. A coin is thrown up in a lift with a velocity u relative to the lift, and the time of flight is found to be t. Find the acceleration with which the lift is moving up. It is given that lift is accelerating up. So the coin experiences a upwards and g downwards. Net acceleration or relative acceleration on the coin will be equal to a plus g upwards. Consider relative movement in y direction on the coin. So y relative is equal to u relative t plus 1 by 2 a relative t square. U relative is given as u. Y relative will be displacement of coin with respect to lift, and that is equal to 0. A relative is a plus g. Since the coin is coming down, so a relative will be taken as minus. This gives a quadratic in t. So either t is equal to 0 or this whole is equal to 0. T cannot be equal to 0, so this whole is equal to 0. This gives value of a as 2u minus gt upon t. Now let us see previous year's JEE questions. First question, a particle moves from the point 2i plus 4j meter at t is equal to 0 with an initial velocity 5i plus 4j meter per second. It is acted upon by a constant force which produces a constant acceleration 4i plus 4j meter per second square. What is the distance of the particle from the origin at time 2 seconds? These are the options given. This question appeared in JEE Mains 2019. So as per given data, at t is equal to 0, x0 is 2 meter and y0 is 4 meter. Ux is 5 meter per second and uy is 4 meter per second. Ax is 4 meter per second square and ay is 4 meter per second square. So we have to calculate x and y at t is equal to 2 seconds. So applying formula, x equal to x0 plus uxt plus 1 by 2 axt square and y is equal to y0 plus ayt plus 1 by 2 ayt square. Putting the values, we get x equal to 20 meter and y is equal to 20 meter. So particle is at q, means x distance is 20 meter, y distance is 20 meter. So OQ will be, as per Pythagoras theorem, under root 20 square plus 20 square. That comes out to be 20 root 2 meter. So option A is correct. Second question, a particle is moving with a velocity v is equal to k times yi plus xj, where k is a constant. The general equation for its path is. These are the options given. This question appeared in JEE Mains 2019. We have to find out the general equation for its path, means relation in x and y independent of time. Given that v is equal to k times yi plus xj, it is made of two components, that is vx and vy. Vx is equal to ky and vy is equal to kx. Vx we can write as dx by dt and vy we can write as dy by dt. So dx by dt is equal to ky and dy by dt is equal to kx. This is our first equation, this is second equation. Now divide second equation by first equation, we get dy by dx is equal to kx upon ky. That is dy by dx is equal to x by y. Cross multiply, so y dy is equal to x dx. Now integrate both the sides within limits. Y within limits y0 to y and x within limits x0 to x. So it comes out to be y square upon 2 within limits y0 to y is equal to x square upon 2 within limits x0 to x, or 1 by 2 y square minus y0 square is equal to 1 by 2 x square minus x0 square. So it comes out to be y square is equal to x square plus y0 square minus x0 square, and this part is constant. So equation is y square is equal to x square plus constant. So option B is correct. Third question, a car is standing 200 meters behind a bus, which is also at rest. The two start moving at the same instant but with different forward accelerations. The bus has acceleration 2 meter per second square and the car has acceleration 4 meter per second square. The car will catch up with the bus after a time off. These are the options given. This question appeared in JEE Mains 2019. Suppose this is the road, bus is standing here and car is standing here. They are 200 meters apart. This is our reference point. At t is equal to 0, both start moving in forward direction with accelerations 4 meters per second square and 2 meters per second square respectively. Suppose after t seconds, car catches up with the bus at this point. In t seconds, bus travels a distance of x meter and car travels a distance of 200 plus x meter. So distance traveled by the car in t seconds is given by x is equal to x0 plus uxt plus 1 by 2 axt square. X0 is equal to minus 200. As this is our reference point, left to it will be considered negative. Ux is equal to 0 as car was standing at t is equal to 0. Ax is given as 4 meter per second square. So x comes out to be x is equal to minus 200 plus 2t square. This is our first equation. Now distance traveled by the bus in t seconds will be x. X is equal to x0. X0 is 0 as this is our reference point. Plus initial velocity of the bus at t is equal to 0 was 0 because bus was standing. And acceleration is given as 2 meter per second square. So x is equal to t square. This is our second equation. Put the value of x in first equation. So t comes out to be 10 under root 2 seconds. So our correct option is option C. Fourth question, in a car race on a straight road, car A takes a time t less than car B at the finish and passes finishing point with a speed v more than that of car B. Both the cars start from rest and travel with constant acceleration a1 and a2 respectively. The v is equal to. These are the options given. This question appeared in JEE Mains 2019. Suppose this is a start line and this is finish line. At t is equal to 0, both the cars were at start line. From the description, it is clear that car A is moving faster than car B. Now apply first equation of motion in a straight line for car A. VA is equal to UA plus A1 TA. UA is equal to 0, so VA is equal to A1 TA. Similarly, VB is equal to 0 plus A2 TB. These are first and second equations. It is given that VA is more than VB by V and TA is less than TB by T. So putting these values in equation 1, we get equation 3. VB plus V is equal to A1 into TB minus T, and equation 2 is VB is equal to A2 TB. Subtract equation 2 from equation 3. We get V is equal to A1 minus A2 TB minus A1 T. In this equation, given quantities are A1, A2 and T. We have to eliminate TB. To eliminate TB, we need another equation. Now apply second equation of motion in a straight line. x1 is equal to x01 plus u01 t1 plus 1 by 2 a1 ta square. This is for car A. x1 is the distance from start to finish line. So x1 is equal to initial displacement is 0 and initial velocity is 0. So x1 is equal to 1 by 2 a1 ta square. Similarly, x2 is equal to 1 by 2 a2 tb square. since x1 is equal to x2, as this is the distance between start and finish line. So 1 by 2 a1 ta square is equal to 1 by 2 a2 tb square. Put the value of ta from here, as ta is equal to tb minus t. So we get this equation, tb minus t whole square upon tb square is equal to a2 upon a1. So we get the value of tb as t under root a1 upon under root a1 minus under root a2. Put this value of tb here. So we get v as under root a1 a2 into t. So the correct option is option D. Fifth question, a passenger train of length 60 meter travels at a speed of 80 km per hour. Another freight train of length 120 meter travels at a speed of 30 km per hour. The ratio of time taken by the passenger train to completely cross the freight train when they are moving in the same direction and in the opposite direction is. These are the options given. This question appeared in JEE Mains 2019. Suppose A is passenger train and B is freight train. Length of passenger train is 60 meter and that of freight train is 120 meter. Speed of passenger train is 80 km per hour and that of freight train is 30 km per hour. To completely cross train B, train A needs to travel 60 meter plus 120 meter, that is 180 meter. Case 1, when both the trains are moving in same direction. So velocity of train A with respect to B is equal to VA minus VB. So magnitude will be 80 minus 30, that is 50 km per hour, or 50 into 5 by 18 meter per second. So time taken T1 for train A to cross train B, T1 is equal to 180, that is total distance traveled by train A to completely cross train B upon relative velocity, that is 50 into 5 by 18. In case 2, when both trains are moving in opposite directions, velocity of A with respect to B will be equal to VA plus VB. That will be equal to 80 plus 30. That is 110 km per hour, or 110 into 5 by 18 meter per second. Now time taken for train A to cross train B, in this case T2 is equal to 180 upon relative velocity, that is 110 into 5 by 18. So ratio of T1 is to T2 comes out to be 11 by 5. So the correct option is option D. Sixth question, a boy reaches the airport and finds that the escalator is not working. He walks up the stationary escalator in time T1. If he remains stationary on a moving escalator, then the escalator takes him up in time T2. The time taken by him to walk up on the moving escalator will be. These are the options given. This question appeared in JEE Mains 2021. Suppose D is the distance from bottom to top of the escalator. When escalator is not moving, only boy is moving. Then the speed of the boy is equal to D upon T1. Let's say it is U. When boy is standing on moving escalator, then speed of escalator is equal to D upon T2. Let's say it is V. When both are moving upwards, then speed of the boy relative to the moving escalator will be equal to U plus V. In this case, time taken by the boy will be equal to D upon U plus V. Now value of U is equal to D upon T1 and value of V is equal to D upon T2. So putting these values, time taken by the boy comes out to be T1 T2 upon T2 plus T1. So correct option is option C. Seventh question, two guns A and B can fire bullets at speeds 1 km per second and 2 km per second respectively. From a point on a horizontal ground, they are fired in all possible directions. The ratio of maximum areas covered by the bullets fired by the two guns is. These are the options given. This question appeared in JEE Mains 2019. Suppose A and B are two guns. They are firing in all possible directions. So bullets will land up at the circumference of these two circles. Suppose this is circle P and this is circle Q. Radius of these circles will be maximum range of the projectiles. Radius of circle P is equal to maximum range of bullets of gun A. Let's say this is R1. So R1 is equal to UA square upon G. This is the formula for maximum range of a projectile. Radius of circle Q is equal to maximum range of bullets of gun B. And that is equal to, let's say, R2. R2 is equal to UB square upon G. So R1 is to R2 is equal to UA square upon UB square. Now squaring both the sides, R1 square upon R2 square is equal to UA to power 4 upon UB to power 4. Multiply by pi in both numerator and denominator. So pi R1 square upon pi R2 square is equal to pi UA to power 4 upon pi UB to power 4. Now pi R1 square is the area of this circle P. And pi R2 square is area of this circle Q. So A1 upon A2 is equal to UA to power 4 upon UB to power 4. UA is given as 1 km per second and UB is given as 2 km per second. So it will be 1 to power 4 upon 2 to power 4. That is 1 is to 16. So the correct option is option D. Eighth question, a butterfly is flying with a velocity 4√2 meter per second in northeast direction. Wind is slowly blowing at 1 meter per second from north to south. The resultant displacement of the butterfly in 3 seconds is. These are the options given. This question appeared in JEE Mains 2021. This is north, this is south, this is east and this is west. Butterfly is flying in northeast direction along the line OP. Wind is blowing along the line PQ. We have to find out OQ. First, we need to resolve U in its horizontal as well as vertical components. That is UX and UY. UX is equal to U cos 45 and UY is equal to U sin 45. So U can be written as UXI plus UIJ, that is U cos 45I plus U sin 45J. Now V can be written as magnitude of V, magnitude of wind into its direction, that is minus J. So V is equal to minus J. Resultant displacement, that is OQ, is given by vector OP plus vector PQ. So OQ is equal to vector U plus vector V. And vector U is equal to U upon root 2I plus U upon root 2J and V is equal to minus J. So addition of these two vectors gives OQ is equal to 4I plus 3J. Magnitude of OQ will be is equal to under root 4 square plus 3 square, that is 5 meter per second. We have to find out displacement in 3 seconds and that is equal to time into velocity. That is 3 into 5, that is 15 meter. So the correct option is option D. Ninth question, a swimmer wants to cross a river from point A to point B. Line AB makes an angle of 30 degree with the flow of river. Magnitude of velocity of the swimmer is same as that of the river. The angle theta with the line AB should be so that the swimmer reaches point B. This is the figure given. This question appeared in JEE Mains 2021. Suppose this is river. Velocity of river water is represented by V. Velocity of the swimmer is represented by U. Swimmer starts at A and wants to reach at B. Line AB makes an angle 30 degree with the horizontal. Swimmer heads in this direction, making an angle theta with line AB. We will resolve these velocity vectors U and V into two components, one along line AB and another perpendicular to AB. Along the line AB components will help the swimmer reach point B. Perpendicular components will cancel each other. Component of U along the line AB will be U cos theta and perpendicular to AB will be u sine theta. V is parallel to this line and AB is transversal. So this angle is equal to this angle, that is 30 degrees. So component of V along the line AB will be V cos 30 degrees and perpendicular to AB will be V sine 30 degrees. So we will equate perpendicular components. So u sine theta is equal to V sine 30 degrees. It is given that magnitude of u is equal to magnitude of V. So sine theta is equal to sine 30 degrees or theta is equal to 30 degrees. So the answer is theta should be 30 degrees. 10th question. When a car is at rest, its driver sees raindrops falling on it vertically. When driving the car with a speed v, he sees that raindrops are coming at an angle 60 degree from the horizontal. On further increasing the speed of the car to 1 plus beta times v, this angle changes to 45 degrees. The value of beta is close to, these are the options given. This question appeared in JEE Mains 2020. I have made 3 figures to describe the scenario. In figure 1, car is at rest. Raindrops are falling on it vertically. Let's say velocity of raindrops is u. In second figure, car is moving with velocity v. Now raindrops appear to fall on it at an angle of 60 degree from the horizontal. That means 90 minus 60, that is 30 degrees from vertical. In third figure, car is moving with velocity 1 plus beta times v. Now raindrops appear to fall on it at an angle of 45 degrees from horizontal. That means 90 minus 45 degrees from the vertical. From this right angle triangle, tan 30 is equal to v upon u, or u is equal to root 3v. From this right angle triangle, tan 45 is equal to 1 plus beta times v upon u. So u is equal to 1 plus beta times v. From these two equations, root 3v is equal to 1 plus beta times v, or beta is equal to root 3 minus 1. Value of root 3 is approximately 1.732. So beta comes out to be 0.732. The closest match is option D. 11th question. A plane is inclined at an angle alpha is equal to 30 degrees with respect to horizontal. A particle is projected with a speed u is equal to 2 meter per second from the base of the plane, making an angle theta is equal to 15 degrees with respect to the plane as shown in the figure. The distance from the base at which the particle hits the plane is close to. Take g is equal to 10 meter per second square. These are the options given and this is the figure given. This question appeared in JEE Mains 2019. We have read that in this particular scenario, range AB of the projectile is given by this formula u square upon g cos square alpha into sine 2 theta minus alpha minus sine alpha, where alpha is the angle of inclination of the plane and theta is the angle made by u with horizontal. So in our case, theta will be calculated as 15 plus 30, that is 45 degrees. Alpha is given as 30 degrees. U is given as 2 meter per second. Putting these values in this formula, AB comes out to be 19.52 centimeter. So the closest match is option B. Last question. Airplanes A and B are flying with constant velocity in the same vertical plane at angles 30 degree and 60 degree with respect to the horizontal respectively, as shown in the figure. The speed of A is 100 root 3 meter per second. At time t is equal to 0 second, an observer in A finds B at a distance of 500 meter. This observer sees B moving with a constant velocity perpendicular to the line of motion of A. If at t is equal to t0, A just escapes being hit by B, t0 in seconds is. This is the figure given, where A and B are two aeroplanes flying at an angle 30 degree and 60 degree respectively with horizontal. This question appeared in JEE Advanced 2014. As per this given figure, line of A is OAR and line of B is MBR. Now at t is equal to 0, observer in A sees B at a distance of 500 meters and at a line which is perpendicular to the line of A. So AB is given as 500 meters. Now in this right angle triangle, triangle AON, angle ANO is equal to 180 minus 30 plus 90. So it will be 60 degrees. In this triangle, triangle BMN, angle BMN is given as 60 degrees and we have figured out angle BNM is also 60 degrees. So third angle, that is angle MBN, will be 180 minus 60 plus 60. So angle MBN will also be 60 degrees. Now these lines are intersecting at B. So angle ABR will also be 60 degrees as this is opposite to MBN. Now in this right angle triangle, triangle RAB, tan 60 is equal to AR upon AB. AR we can figure out as velocity of A into time taken to reach R. T is equal to 0 at A and T is equal to T0 at R. So time taken is T0 and velocity of A is given as 100 root 3 meter per second. So AR will be equal to 100 root 3 into T0. AB is given as 500 and value of tan 60 is equal to root 3. So T0 comes out to be 5 seconds. So the answer is 5. In the next video, we will start 4th chapter, that is laws of motion. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.